Hello students, today we will discuss curve tracing for polar curve. In the previous two class in curve tracing, I have already discussed about curve tracing for the Cartesian form and curve tracing for the parametric form. Now today I will discuss about curve tracing for polar curve. So now polar curve means what? In this form, the equation of the curve will be look like r is equals to f of theta. So today we will discuss this topic with an example. So the curve of the equation is r is equals to a into 1 plus cos theta. So as we know, whenever we want to trace a curve, first we have to check about symmetric. The curve is symmetric about your initial line or symmetric about perpendicular to the initial line or symmetric about the pole, that you have to check. So for polar curve, you have to put theta equals to minus theta, and if there is no change in the given equation, then it is no change, then the curve is symmetry about initial line. Okay, so what is initial line for polar curve? So we know for polar curve, this is my initial line, this is my pole O, and this is my initial line OX. So if we put theta equals to minus theta and there is no change in the given equation, therefore we can say the given equation or the given curve is symmetric about the initial line. Next, we will put theta equals to pi minus theta, and if no change, and if there is no change, then if no change in the equation, then it is symmetric about perpendicular to line to the initial axis or initial line, perpendicular line to the initial line. Okay, so that means we will put theta in place of theta, we will put pi minus theta, and if there is no change, then that means it is symmetric about this line. This is perpendicular to my initial line, so symmetric about this line. And last, if we put theta equals to pi plus theta or r is equals to minus r, both case, okay, in this place you have to check both condition, theta equals to pi plus theta or r equals to minus r. If any one of them satisfied, then it is symmetric about pole. Okay, so we have understood how to check the symmetric for polar curve. Now take the example, whatever which one we have taken here, that is r equals to a into 1 plus cos theta. So first what we will do, we will put theta equals to minus theta. So just put r is equals to A into 1 plus cos theta replaced by minus theta. Now we know cos minus theta is actually give you cos theta. So that is actually your r is equals to a into 1 plus cos theta. So whatever the given equation, and after substituting theta equals to minus theta, there is no changes in the equation. So that means we can say the curve, this curve is symmetric about initial line. Okay. Next, check is it symmetric about perpendicular line. So if we check it, so that means you have to put in place of theta pi minus theta. Okay. So symmetry about perpendicular line. For checking symmetry about perpendicular line, we have to put theta equals to pi minus theta. So that means r is equals to a into 1 plus cos pi minus theta. So that means a into 1 minus cos theta, because this is in the second quadrant. Okay, and in second quadrant cos is your minus, so therefore it is a into 1 minus cos theta. So now you can see that your equation is changed. Here equation is r equals to a into 1 plus cos theta, but here equation r is equals to 1 minus cos theta. So that means it is not symmetric about initial line. Okay, not symmetric. It is not symmetric about perpendicular line of initial line. इनिशियल लाइन का जो परपेंडिकुलर लेंगे उसके रिस्पेक्ट पे सिमेट्रिक नहीं है. नेक्स्ट यू हैव टू put theta equals to pi plus theta or r equals to minus r. See, very easily you can see here, if we put r equals to minus r, so that means obviously equation will be changed. So therefore this is not satisfied, and for this one theta is equals to pi plus theta, so that means cos pi plus theta. Okay, cos pi plus theta, that means it is in the third quadrant, and third quadrant cos is negative, so that means it will give you r equals to a into 1 minus cos theta. So that means again equation is changed, so therefore it is not symmetric about the pole. Okay, I hope all of you have understood how to check the symmetric. Next, origin. So we will check. In the previous classes also we have done it. That second one is the given curve which passes through origin or not, that you have to check. So now you just see this is your polar system. Now this is your P is equals to r theta. So which one is your r? This is your r and this one is your theta. So any equation passes through origin. That means what? Any curve passes through origin. So that means here value of r is 0. So that means you just put r is equals to 0. Okay, put r is equals to 0. And if you find finite value, if you got finite value of theta, then we can say that it is passes through origin. So just check this example. So r, that means will put 0, that is a into 1 plus cos theta. Now we know that a is not equals to 0, so that means cos theta is equals to minus 1, so that means cos pi, so that means theta equals to minus pi. So that means it is your finite value, so therefore I can say that given curve passes through origin. Passes through origin. Okay, that also done. Now what is the third condition for tracing curve? asymptote. Okay. So for checking asymptotes of a polar curve, what you have to do, you have to put r equals to infinity, and from there find a finite value of theta. If you get a finite value of theta, so that means your asymptote is exist. Okay. And if you did not get, if you cannot find the value of theta finite, you cannot find the finite theta value, then you can say that your curve has no asymptotes. Now just see, this is your curve r equals to a into 1 plus cos theta. Now I am putting theta equals to infinity. So infinity equals to a into 1 plus cos theta. Now here you all of we know that cos theta, value of cos theta is always lies between -1 to +1. So cos theta cannot give you infinity, and here it is 1. So that means this portion cannot give you 1 for any particular value of a. It cannot give you infinity for any particular value of a. So therefore you cannot find finite theta. So that means no finite value of theta exists. So therefore no asymptote. Okay. नेक्स्ट हम लोग क्या सीखे थे, some special points. Okay, but here we will first find here region. Okay, so this is something different, not different. So next one is region. So for finding the region, you just see in the given equation only cos theta is present, and we know value of cos theta is obviously less equals to 1. So now if you want to find the value of r, so value of r is 1 plus cos theta. Now what is the minimum value and what is the maximum value of r, we can say. So what is the maximum value? Maximum value cos theta is 1, positive 1. So 1 plus 1, 2. So that means 2a. And what is the minimum value? Minimum value we know that cos theta is -1. Cos theta can be -1. So that means minimum value is 0. So therefore my r lies between 0 to 2a. Okay, 0 to 2a. So that you have to find in the region portion. And next यहाँ पे हम लोग एक्स्ट्रा जो चीज करेंगे, दैट इज वी विल फाइंड द टेबल. व्हाट इज द टेबल? फॉर सम वैल्यूज ऑफ थीटा वी विल चेक व्हाट आर द वैल्यूज ऑफ आर. ओके, theta, for some values of theta we will check what is the value of r. So now just check, if we put theta equals to 0, if we put theta equals to 0, so here theta equals to 0, that means cos theta is 1. So that means r is 2a. Okay, because it is 1, it is 1. So 1 plus 1, 2 into a, so 2a you will get. Now if we put theta equals to pi by 6, it is 30 degree. So at 30 degree, what is the value of r? At 30 degree, what is the value of cos theta? What is the value of cos theta at 30 degree? We know the value of r is √3 by 2. So cos theta, the value of cos 30 is √3 by 2. So that means 1 plus √3 by 2 into a. So therefore this is your 1 plus √3 by 2 into a. Now check pi by 4. Pi by 4 means 1 by 2. Sorry, 1 by √2. So 1 plus 1. Okay, no need to check. Acha, ठीक. For pi by 4, you will get 1 plus 1 by root 2 into a. For pi by 3, what you will get? Cos theta will give you 1 by 2. So that means 3 by 2 into a. And if it is pi by 2, what you will get? If it is pi by 2, you will get a. Now, similarly, you just find the values for 120, 135, 180. And you can see at 180, the value is pi. Okay. 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 Now, the last part of this portion, this is extra, which you have not find. Sorry. Now, the last part is you have to check about the tangent. So, for the polar curve, there is a angle phi that you have to find. What is that angle phi? That is actually, suppose this is your curve and you are drawing a tangent at that point. Now, angle between the radius and the tangent is actually phi. The angle between the tangent and the radius is actually phi. So this is my phi. So we have to know the relation between phi and the theta. That you will calculate by using the formula tan phi is equals to r into d theta dr. Now, my given curve is r equals to a into 1 plus cos theta. So, my dr d theta is equals to minus a sin theta. Now, we will put it. So, r equals to a into 1 plus cos theta and d theta dr. That means this is minus a sin theta. So this and this will cancel. 1 plus a cos theta, that means 2 cos square theta by 2, and this one is 2 sin theta by 2 cos theta by 2. So this will give you minus 2 cot theta by 2. So that means this one we can write. So this will give you cot theta by 2, and this one you can write cot pi by 2 plus theta by 2. So therefore phi is related to theta by 2 plus pi by 2. Now from here you can see, so this is the relation between phi and theta. Now, if your theta is equals to 0, then you can see the value of phi is pi by 2. So that means when your theta is equals to 0, then your tangent is perpendicular to the x-axis. Okay, or the in a perpendicular to the radius. And when is your theta is equals to pi, you can see when is your theta is equals to pi, then your phi is actually theta by 2, means pi by 2 plus pi by 2. So that means pi. Okay, so you can see that when theta is my pi, then the angle is tangent angle is pi. Okay, Now here also one thing I want to mention, you can see when we are finding the value of r, if I increasing the value of theta, so at theta 0, the value of r is 2a, and at pi by 6, the value is 1 plus root 3 by 2 into a, and very easily here we can say that my 2a is greater than this. Okay, and similarly this is greater than this one is greater than this, like that. So that means the value of r is continuously decreasing. Okay, so now just see, if we compile all the information what I have get, then you just see, so what we get, this is my initial line and this is my perpendicular line ox. Now, at initial line, your value r, when your theta is 0, so that means this line is theta 0 and value of r is 2a. Okay, and now theta is increasing, so and theta is increasing, so that means theta is moving like that, and the value of r is decreasing, so that means your curve will be coming like this. Okay, this, and when theta is pi, value of r is 0, so like this. Okay, and also you can see, if we draw a tangent here for this curve, if we draw a tangent, sorry, and also we know that my curve is symmetric about the initial line, so it obviously look like this. Okay, now here one thing I want to mention, that when is your theta is 0, your phi is pi by 2. What is phi? Phi is angle between tangent and radius. So this is your tangent at that point and this is your radius. So here your phi is pi by 2. Okay. And again, in this case, when theta is pi, so that means this case, theta is pi, this case. Okay. यहाँ पे theta pi होता है. So in this case, the tangent is actually your, which one is your tangent? This is your tangent. Okay, now you can see that this and this angle is pi. Okay, so I hope you have understood that how to find or how to tracing a curve for the polar equation. Now also I'm giving an example to all of you. You people please try to solve it, that the try to tracing this curve, that is r square equals to a square cos 2 theta. Okay, so this is I am leaving as an exercise. You people please complete it and you can verify that your curve will be look like this. This is A, this is B. Okay, so I am leaving it for homework. Thank you for watching the video.